Je regarde parce que d'habitude, mon l'écran.
Okay, and our first talk of this second session will be Sarah Antier, talking about SkyPortal and how you can use it to enhance your time domain astronomy.
Hello, so thank you for the invited talk. It's a pleasure. So I will talk about SkyPortal, which is a kind of similar of BHTOM services. Um, so first, SkyPortal help for the O3 and O4 campaign. And so since we are in ACME workshop on gravitational wave, I would like to show a bit where we are in terms of gravitational wave alert for O4A and O4B. So these are all the events that we are detected at O1, O2, and O3 for offline catalogs. And then I have highlighted, sorry, wait. Yeah, I have highlighted the black hole that we are detecting, O4A and O4B. So this plot is up to July 2024. So since then, we have detected more events. We have sent in more alerts to the community because I'm part of LIGO. That's why I say we. And what you can see that, all the astronomer and LIGO people were very excited about this campaign. And finally, there were only few NSBH alerts reported. Maybe some of them will be not confirmed. And no BNS confirmed event so far. So even though we have some events, and the idea is if the portal helps to detect any counterpart of this NSBH, did we miss the counterpart because we didn't have the tools, or is because maybe the ejecta was not enough, etc., etc. So can we also put some constraint about this follow-up? And for that, to put some constraint, you need to have tool to be able to pave the sky map and observe at the right time. So when you do gravitational wave follow-up, or Chem3net follow-up, anything, you, as an astronomer, so taking my head as an astronomer, to understand if whether or not you will go or not for this, because it is telescope's time. And so it's restricted because it's not only time of observation, but also people behind that will be wake up and so on and so forth. So then you perform a multi-band follow-up and maybe find a discovery. So I saw in the talk this morning that there were a lot of follow-up on sources, but remember that multi-messenger is also finding some candidate, like in white area. So that's why there are discoveries, like maybe it's a discovery, maybe there are candidates, and then you do your online characterization that Fabien, you talk about it. And then at the very end, do your event properties extraction. And so since we are rising with IA, all these steps can be, IA can be careful about that. So just what is amazing in multi-messenger is that from the, let's say, the trigger point of view, it's just sending a bottle into the sea and say, yeah, we have done our job. At LIGO Virgo, we just wake up in some sense of 10 minutes, or as one satellite, and then this is this, and then you need to follow up and take hours and sometimes weeks on the follow-up point of view. So as an astronomer, e.g. follow-up astronomer, you need to organize your people, right? Because otherwise you are too exhausted. And LIGO Virgo is like a year or more than a year now. And you need to organize your rota. If you have automatic processing to filter your source of interest. And even that, if you delegate to some student, to some colleagues, they need to identify if it will be important, how is the degree of agency. Can the team on shift solve it himself? Do it need the manager? And of course, as more as we are going forward with observational research, there are new tools, there are new practice. So you need to have a very learning curve that is difficult to handle for the manager. And so that's why it gets tired, everyone. So I don't want to depress you, but this is the reality. So brokers, that's fine. But in fact, follow-up is a hard pathway. And so people in the room have done that over 20 years and still there, right? So there is another thing that is difficult is about the tool and the service. And we discussed a bit with that with Emily is about like, there is a lot of processing and there is a lot of tutorial. And this tutorial is getting to be updated based on the discovery. And so it's hard to maintain everyone up to date with all the documentation. And so as researcher, it's true that sometimes we had updating our documentation. So usually, sometimes when we have this process, it's go up to the expert or the manager that need to handle like very tricky situation. Of course, more and more it is easy task, more and more you can automatize, and more you replace the simple task by computers. So this is the things. So, okay, we don't do DW, neutrino, follow-up on our hand, and there are a lot of tools going on that Fabien, you discussed that, so I will not come back to that. But as I said, I would like to point out that for me, multi-messenger is about unlocalized sources, so more than an event that has more than r-second certainty. So you need to really detect this optical candidate. Sorry, I focus my talk on optical follow-up. And so there have been a think tank, I don't know how to say it, in USA in 2004 to report, okay, what we're gonna do, what are the services that we need to do for multi-messenger. And from this workshop, what's come out of this is that, okay, we have tool, we can have grants to develop new tools, but how it is to maintain this tool, right? Because when you have a grant, it's like, I will do a major upgrade or things like this. And so it is very hard to find grants for maintaining tools. And so that's why, the NSF proposed some grants after to maintain the tools. And so this is what we try, I think, to do with ACME as well. So about the follow-up, there are, of course, automatic telescopes, but there are lots that are not automatic, operating either remotely or even manually by operators or astronomers. And so we need to rely on these PI telescopes still. And so the one not managed by agency or even tougher. And for example, honestly, when I, for example, collaborate with Chinese colleagues, is about like discussing with them on WeChat. The other one will like WhatsApp. The other one will like to receive a message by email. And so this is all this heterogeneous data that we need to handle compared to the one that at the front of the triggers, right, or broken. So how to solve it? Like we have a lot of data to look at it by a lot of people doing it at the same time. And we are in a race over time. So regarding your expertise, you want to see quickly the data, but you don't want, it requires some personalization. And so this is why it is difficult to develop some service like this. And also, what is important is that you are not the only one. You want and need to report automatically to other collaboration and other colleagues. So we need more and more automatization for time domain. And SkyPortal and SciencePortal in particularly are the ones that try to answer to this question. So here I will talk about SkyPortal, but of course BH term is a bit the same. So what is the solution that we need to handle for observational research is to receive large amount of data that is also doing well by AstroColibri, to be able to scan upcoming data stream, like the brokers, to visualize what is going on and trigger additional resources for determine if it is good or not to continue on these sources. And have observation plan, visualization, and of course reporting to the community. So I didn't hear this morning. I hear about like GCN, but there is of course TNS, and that is largely used by the optical community. So what is SkyPortal? It's a project funded by John Bloom from Berkeley, actually managed by Michael Crouching from UMN, and it's a French-USA project. So I'm proud to say that, I mean, all the engineers are French, even the one in USA. And so there are developers at Caltech, at Minnesota, and in our side at EGC Lab. One person is actually just arrived and funded by ACME. And we have some students that work on this SkyPortal project for maybe it was starting in 2020, 21. Don't remember, but we try to keep up to date. And how looks SkyPortal? So it's basically a science portal, let's say, when you receive your multi-messenger events. So when we call GC7 event is the one not localized, okay? And these are the sources, the one that you can point into the sky, so the arc second. So the sources, you can have multiple sources attached to a GCN event. You have your network of telescopes, and you have discussion between your group. So what we're going to do for ACME is just that this tool is going to be accessible to all ACME user. Of course, SkyPortal was public already, but you need to have a server, you need to install it, parameterize. Here it's just like you create an account, and you have, so just come back. Yes. You just have your accounts from IAM. So if you're registered in Europe with an institution, you just subscribed, and then you create your group. You can be just yourself on your group, right? Or you can be a big collaboration with group. And so for ACME, what we need to do is to just control the data sharing and data access, right? Because for the moment, it's only used by one collaboration. Okay, so this is what globally is doing SkyPortal, and I will come back about the how to. But for me, a tool is needed if it creates great results of science. So I would like first to show what we have done so far with SkyPortal. The first is, we are in a gravitational wave workshop. So the first is about gravitational wave and multi-messenger astrophysics of O4. So if I come back to my first slide, these are 1, 2, 3, 4 NSBH alert candidates from O4. Okay. Some of them are confirmed, some of them are not confirmed, but we are still waiting the O4 catalogs. And these are follow-up triggered by 13 teams. So for example, in optical, TESS, GECO, ATLAS, GO2, ZTF, Grandma, Saguaro, DCAM, Winter, and other teams like Mergirk, Wacklem, and Magellan. So in this work, run by Marion Pilas and I, we collect all the data that was accessible. We contact this team. And we created, thanks to CDS tool, large sky map for all the coverage on this alert, right? So multi-messenger is also able to collecting all this data. And we work closely with those teams that I named so that they reanalyze the data and that we can put constraints. So this is the magnitude. Of course, it's per filter, but this is the magnitude coverage. This work can be done, of course, with ACME. You just need to have people to collaborate and to give, the high-level product. And I hope that this kind of paper will be done with ACME, because right now it cannot be done with things like Virgo, right? Because there is no partner anymore. And what we can see that the general so it is also with this team that did not participate to the paper, but giving a result via treasure map. I will come back to that. And so what you can see is it the general effort able to constrain GW coverage, or give ejecta constraint? So you can see that 1% have been covered of the sky map of this event, 37 for this one, and it was a 1D detector, so it's quite significant, etc., etc. So what we can see is that compared to those three campaigns, the O4, let's say that the community was quite efficient to pave the sky. The question is the community, with all the tools, was able to observe at the right time? And so this is based on, so you have day over T0, and this is based on, and the peak shows the peak, the maximum peak of a kilonova. So if you want to see the kilonova, the brightest will be at this time, 1.2 day for NSBH measure, because the kilonova is not the same for BNS. And this is in color, the observation made by the community in total. What you can see is that the community can start very quickly. Oh, there is a gravitational wave alert, let's go. Or can, go down to do some revisit. And so what we encourage from this paper is maybe that we need to have revisit, not only go and then nothing, because we need to cover the peak of the kilonova. So then, I don't know how many time I have, maybe I need to move on. But so we talk about the where, we talk about the when, now we talk about the sensitivity. Were the observation enough to constrain this ejecta? And so if you look at kilonova grids, let's say all the kilonova possibilities that you have, and you create some uncertainty of LIGO, let's say, based on your grid, and because you know the distance from LIGO Virgo, but be careful, because if you look at this sky, maybe the distance will be that one. And if you look at another part of the sky, the distance by LIGO Virgo will be a bit different. And you can see, for example, that DCAM observation, they did not detect a kilonova and was below. So it means that, okay, DCAM data were enough to rule out any kilonova signal. And you do it the same for all the telescope and so on and so forth. So you know that LIGO Virgo is not releasing MCHIRP that will help to exclude some of the parameter space of the kilonova. But we have the P astro, so whether it is a certain probability to be BNS, NSBH, or BBH. And so with this P astro, you can already constrain the parameter space on the ejecta mass. And so, just include part of your parameter space on the kilonova, and this is what we did in this paper. And so what we show is that, for example, for 240422 ED, the most popular event in 04, we can exclude, thanks to the general effort of all the community, that there was no kilonova for any type for an SBH. And this is kind of multi-messenger results that we can do without detection. So now I'll go move a bit more quickly. But okay, what is the link with SkyPortal before? Just forget. It's because the plan of DCAM, ZTF, and GRAMA was made with SkyPortal. So this kind of tool helped to really, do this science. With SkyPortal also, and with the help of ZTF, it's also helped to find GRB from unlocalized event, like the GBM event. And so this was a significant discovery of a short GRB that was finally classified as a collapsar. And another discovery, thanks to SkyPortal and this suit, was about TDE also. So there are compact, exposing events done to SkyPortal. So now I will take a look, and I wanted to emphasize, in fact, first the physics done with SkyPortal. But I already say you can receive your GCN event, you can manage your source. You can manage the people that can be on shift and that will manage this follow-up. You can have your observation plan. This is how it has been done with the GBM trigger to detect the discovery of the afterglow of GBM. Okay, so you can define how is your observation plan if you want to tile the one that are immediately or perform some revisits. This is up to you. Now this is the source page. So let's say that you have some candidate or it is a confirm. You can, whatever you want, say something, a report, you can see in the template, right, to see if there is a nearby host galaxy. You have the possibility to have to create your light curve based on a GCN, and you can plot it in log, which is useful, etc., etc. What you can do, you can follow up your best follow-up. So I took Taro because we are in Toulouse, and the PI is in Toulouse. So you can trigger Taro or any API. We are working, for example, triggering CFH, that is part of ACME. You can do spectroscopy. Personally, I'm not a spectroscopy person, but it seems like you can do a few items about it. You can do the scanning that I was talking about, like to reject, like we did for GBM. And you can go up to, remember my flowchart, chart, to very quick analysis like slope, but also Bayesian inference quickly based on the service that you want. So this is all integrating in a single tool. If you use different toolkit to do each step, of course, maybe it will be a bit more, you will have more functionality, but what I find cool in SkyPortal is to have all this feature in one science platform. So I would like to finish my talk that given the experience that we have in gravitational wave, I mean, at least with my collaboration in GRANMA, I didn't talk too much in GRANMA in this talk, but we are looking for preparing LSST and chemistry-net science in collaboration with Think and using SkyPortal. And we are still debating, like every on our colleagues, how to observe this. And it's not evident either on these two new triggers, let's say, for us. And so, yeah, if you want to collaborate with us to think about it, like please let us know, because I'm sure that we still need to think about it. Thank you.
Thank you, Sarah, for the talk. Questions from the audience or online?
Thanks very much, Sarah. So this iCare thing that you've just shown us how to use and so on, you said you can sign in with your institutional login if you are connected. For those of us whose countries decided that we would get out of the EU, are we still able to log into that if we want to? I voted to stay, please.
Yeah. So I talk about SkyPortal, but iCare is, in fact, is the European French version. Like the American sometimes was saying iCare, sometimes was saying it's free because it's customable to ZTF. But for ACME, we will customize iCare. Like, okay. But yes, I think it's about the subtraction. What we don't want is to manage, in fact, create a new account, etc. We want to go, so we fight to not get access, for example, to Google, like you do, because it's not, it's not good for science. But yeah, I think
we'll be able to get access.
Yeah.
Okay, thank you.
But it's not now, right? We need to make development. Right. Okay.
I think it's very nice to have inside of ACME to the iCare, but I think one of the things, you flash Fritz, you show iCare, but by in the transition from one to another, a lot of information is being lost because we in Fritz, for instance, and I've been member of this for a while, most of the time, and there's all the comments and all the logs, and so there's a lot of information. Also, the spectroscopy data is mostly private, and so it's like a private club. And in iCare, we would be then starting from scratch. I guess so I'm interested in if that's true, and if which data should we load into it so that it becomes valuable. So that it actually is. I guess the motivation comes if there's value added. It's not just the portal; it's also what you stick in. And Fritz was was so good because it had all the spectroscopic information, for instance, inside. And so could you say what data is will be there to from the beginning?
Yeah, so you're talking a bit with your broker hat. I mean, I cannot control the ZTF privacy data, right? You talk about spectra taken under the collaboration of ZTF.
No, yes, of course, but we
Yes.
then have to think about. I guess it's a question. We have to think about how to replace it. I mean, to make it, for instance, ePesto. Can we? There are a lot of resources
but
in Europe too, and we need to make sure that they actually enter efficiently. ZTF, was so successful because they worked this out. It was not just this. I mean, it grew sort of into something but it was not just the portal. It was also the people feeding the data into it.
Yeah, but it's up to ACME astronomer to fill this page for the moment, as you said. So question number one is if ZTF or the authorized to transfer, because for example they want something public, we can transfer. The plan is to transfer some Fritz data to iCare or iCare to Fritz, right? Because there are some, as you said, some spectra that's are already public in TNS, so there will be some possibility to import that from iCare to Fritz. But then it's about the astronomer is always a tool, right? A service needs to be used by, a community. For the moment, you talk about ePesto. I don't know if ePesto would like to use this tool, right? It's not on me to decide.
No, but it's okay, but we need to facilitate this. I mean, we need to start the conversations. I think if this is meant to become successful, we need to not just say, here's a tool, you can use it, but we have to think about how to, bring people together to actually use it. I mean, because otherwise it will not be competitive, I think, with other,
we need to
approaches.
We need to discuss with them what are their needs to be customized for this group or that group or etc. Right? For example, we talk a bit about DCAM, for example, but DCAM is independent from ZTF. Maybe they will use this tool. I mean, it's one by one collaboration. But I'm not granted. We are granted to just deliver a tool, right? So it's just on the ACME community to discuss with them, etc., etc. But it's the same for the same tool, right? If you have BH-Tom, if you have AstroColibris. Yeah, understand that we need to be active to show what are the things or develop some. So first, the grant is for the service, right? So it's not about
we are granted a little bit of money. We do a lot more than we usually are granted for in order for the product to make sense. So I think that's I think I mean you're right that it's not on you, it's on us, but we need to sort of
we
be
need to make sure that the tool is customizable for the need or if they need. But I think it's on another work package, right? We need to connect with that, right?
I don't know which. I'm not even thinking in terms of work packages here. Okay.
Okay.
If there are no further questions, I will ask one final. Potentially, I misunderstood, and if so, I apologize. It looked as though you were sharing analysis and analysis tools through this platform with the corner plots. Is that is the idea that some of the analysis can be hosted on the platform, or is it just that people are doing their analysis locally and then sharing it with their teams?
No, you can run your analysis via the service. You need some computing resources, but you can, again, if you're part of this group, you can do it. But if you don't have access to the data to this group, then you don't see it, right? It's just about like transfer of product that is not only the light curve, maybe the Bayesian inference product.
if there are no further questions, then we'll thank the speaker again. And